Good morning, good afternoon, everyone. Thank you for being here. My name is Vaibhav Anil Vora, and I am a senior technical account manager working at Amazon Web Services. I'm really excited to talk to you today about a topic that's become increasingly critical in our interconnected world: zero trust security. The title of my talk is Zero Trust Security: From Perimeter Defense to Continuous Verification in the Modern Enterprise. For decades, our approach to cybersecurity was largely based on a model we often call the castle and moat. We built strong perimeters, our firewalls, and intrusion detection systems to keep the bad guys out. Once you were inside of that perimeter within the corporate network, there was a significant amount of implicit trust. We assumed that anything inside was safe. But here's the reality: the digital landscape has changed dramatically. With the rise of cloud computing, mobile workforces connecting from anywhere on any device, and complex supply chain integrations, those traditional network boundaries have essentially dissolved. The moat has dried up, and the castle walls have crumbled in many places. This is why zero trust isn't just a new buzzword or a product you can buy off the shelf. It's a fundamental paradigm shift in how we think about security. At its heart, zero trust eliminates that implicit trust. It demands continuous verification for every interaction on the network, regardless of where it originates. Whether you are inside the traditional network or outside, you have to prove who you are and that you are authorized to access a resource every single time. Over the next few minutes, we explore the evolution that brought us here, the core principles of zero trust, why it's so important right now, its key components, and where this approach is headed. To understand where we are growing, it helps to look at where we've been. Security models don't just appear out of nowhere. They evolve in response to changes in technology and the threat landscape. Think back to the traditional model. As I mentioned, this was our castle and moat era. We focused heavily on the perimeter. Our main defenses were at the edge of the network. Inside, things were relatively open based on that implicit trust. This worked to a degree when most of our valuable were at the edge of that network. And also, it worked to a degree when most of our valuable assets and users were inside that well defined boundary. It created a clear sense of trusted and untrusted zones. But then came the digital transformation, and this was a game changer. Organizations embraced cloud computing, moving applications and data outside the traditional data center. Our employees became mobile, working from homes, coffee shops, airports, accessing corporate resources from devices we didn't control. The Internet of Things, or IoT, added countless new devices connecting to our networks. These changes shattered those clear we didn't control. And these changes shattered those clear perimeters and exposed critical vulnerabilities because our security still relied heavily on those new porous boundaries and that internal implicit trust. This is what led to zero trust emergence. Security professionals realized we couldn't simply patch the old model. We need a completely different philosophy. The principle that emerged was never trust, always verify. This means we don't trust any user, device, or connection inherently, regardless of where they are located or originate on the network. Every single access attempt needs to be authenticated and authorized continuously. Moving forward, let's drill down into that foundational principle: never trust, always verify. It's simple in concept, but profound in implication, built on a few key pillars. Firstly, And perhaps most critically is continuous verification. This means that every time something, a user, a device, an application tries to access a resource, we treat that request as if it could be potentially hostile. Even if they were verified a minute ago, we don't implicitly trust them for the next very access. This requires robust identification, verification, mechanisms for all entities. It's not just about logging in once. It's about validating access for each specific interaction. Secondly, we have least privilege access. This is about granting entities only the absolute minimum permissions they need to perform their legitimate function. If a user only needs to read a specific document, they shouldn't have right access to other systems. This limits the potential, the blast radius, if an account is compromised. An attacker gaining access to an account with least privilege is far less damaging than one with excessive privileges. And thirdly, comprehensive monitoring. In a zero trust model, you need visibility into everything that's happening across your network and systems. All traffic, all access attempts, all users and device behaviors. This constant monitoring and analysis is essential for detecting potential threats, whether they originate from outside or from inside the network. Without this visibility, you cannot effectively verify and respond. In this slide, we will see why the shift to zero trust, not just a good idea, but absolutely is essential right now. The factors driving it are the realities of our modern IT environments. Cloud computing means that our application and data are distributed. They live in on-premise data centers, in one or more public clouds, and corporate networks increasingly at the edge. Securing this distributed landscape with a single perimeter is impossible. The mobile workforce is here to stay. People work from anywhere, using a variety of devices. We can't rely on them being inside a secure corporate network. Access needs to be secured, regardless of location or device. Supply chain integration. It means our partners and vendors often need access to our systems and data. This creates complex interdependencies and expands the network of who needs access. Securing these connections based on old trust models is risky. All of these factors contribute to a significantly expanded attack surface. There are more ways for sophisticated threat actors to gain unauthorized access than ever before. Zero Trust is designed to address this expanded surface by focusing security controls closer to the resources being accessed, rather than relying on a parameter that no longer effectively exists. Let's see, it's worth briefly touching on the history. The concept of zero trust wasn't born overnight. It really began with a recognition of parameter limitations. Security professionals observed that once attackers bypass the traditional parameter defenses, they could often move laterally throughout the internal network with very little resistance because of that implicit trust that I talked earlier. This was a major vulnerability understood. This recognition was often a direct response to sophisticated attacks. We saw attacks that successfully breached the perimeter and then lingered undetected inside the networks for extended periods, causing significant damage. This highlighted the failure of relying solely on perimeter security. So, the conceptual shift happened. Instead of focusing on where the access requests came from, inside or outside, the new thinking was to verify who and what was making the request and what they were trying to access, regardless of their location. It was about verifying everything before granting access, the birth of zero trust idea. Let's revisit these core principles because they are the foundation upon which a zero trust architecture is built. Firstly, authentication and authorization for all traffic. This is non negotiable. Every single connection, every data request must be authenticated and authorized. Identity becomes the primary security control point, the new perimeter, if you will. Secondly, microsegmentation. This is a critical technique to limit lateral movement. Instead of having large flat networks, we divide them into small isolated zones. If one segment is compromised, the attacker can't easily hop to other parts of the network. It drastically limits the potential blast radius of an incident. Thirdly, dynamic policy enforcement. Security policies in zero trust are not static. They are continuously evaluated based on a variety of risk factors during the session. Is the user's device compliant? Is their location unusual? Is their behavior typical? Policies adapt based on this ongoing assessment, not just a one time authentication event. And finally, comprehensive monitoring again. This principle underpins everything. You need deep visibility into all networks, activities to enforce policies effectively, detect threats, and respond quickly to incidents. This next slide really highlights the contrast between the old way and the new way. Look at the traditional security model. Its primary focus was on building that strong perimeter. Inside the networks were really open. This created those distinct, often overly simplified trusted and untrusted zones. A major drawback was that it granted excessive privileges once a user authenticated at the perimeter and was inside of it. It also often resulted in security controls being implemented inconsistently across different parts of the environment. And as resources migrated between on premises and the cloud, these perimeter cloud based control created significant protection gaps. Now, compare that to zero trust architecture. The fundamental starting point is assume a breach. We operate as if a threat actor could already be inside or could compromise any connection attempt. Because of this, we implement consistent verification processes for all access requests, regardless of their source or location. The focus now shifts from securing the network segment to protecting the resource itself, the data, the application. Every single access is verified based on multiple factors: user identity, device posture, context, etc. This approach ensures consistent security enforcement across all environments, whether it is on prem, in the cloud, or accessing resources from a remote device. Implementing zero trust requires building a security architecture with several key components working together. First, you need robust identity verification. This is foundational. You must be able to strongly authenticate both user identities and device identities before making any access decisions. This goes beyond passwords and often involves multi factor authentication, behavioral biometrics, and verifying the security posture of the device. Next is microsegmentation. We've talked about its importance. This requires technologies that allow you to create those granular network divisions to isolate sensitive resources within protected zones. This prevents the lateral movement. Then there's security information management. You need systems like the CM platforms that provide comprehensive visibility by collecting and identifying potential threats through behavioral analysis. Finally, you need policy enforcement points. These are control mechanisms situated throughout your architecture. They could be security gateways, proxy servers, next generation firewalls, or host based agents that evaluate every access request against your defined security policies. These decisions are based on all the factors we've discussed: who the user is, what device they are using, where they are, what resource they are trying to access, and the current risk assessment. Moving ahead, let's spend a moment more on least privilege as it's a cornerstone. It's not just about basic access rights, it involves more dynamic approaches. Just in time access means providing elevated privileges only for the specific task that requires it and only for the duration of that task. This significantly reduces the window of the opportunity that an attacker has to misuse the elevated permissions. Attribute based controls allows for dynamic access decisions based on a wide range of contextual factors beyond just the user's role. Things like the device health, location, time of delay, and the sensitivity of the data being accessed. Identity governance is the ongoing process of reviewing and managing user identities and their access rights. Are the assigned permissions still necessary? Have any rules changed? This helps ensure that the principle of least privilege is maintained over the time. Ultimately, it all boils down to ensuring that users and systems only have the minimum necessary permissions required to perform their legitimate functions and nothing more. Microsegmentation is a key zero trust strategy to contain threats. How do we achieve it by? One approach is through software defined networking. Software defined networking, SDN, allows us to define security policies centrally, independently of the underlying physical network infrastructure. This makes it easier to enforce consistent controls across diverse environments, whether it's in your data center or across multiple cloud platforms. Another powerful technique is application layer segmentation. Instead of restricting communications based on network addresses like IP addresses and ports, which can be complex to manage in dynamic environments, we restrict communication based on the identity of the software or application itself. This provides a more robust level of protection that remains consistent even if the underlying network infrastructure changes. Workload isolation takes this even further, establishing security boundaries at a very granular level, such as individual containers or processes. This means that if one workload is compromised, the potential damage is confined to that specific workload, minimizing the blast radius. Crucially, implementing effective microsegmentation requires dependency mapping. You need a comprehensive understanding of how your applications and services communicate with each other. What are the dependencies? What communication flows are legitimate? And mapping these dependencies is essential for defining the correct segmentation policies. Remember, zero trust is continuous. It's not a one-time check. This is where continuous monitoring and adaptive authentication comes in. It starts with baseline establishment. You need to understand what normal behavior looks like for your users, devices, and applications. What are the typical access patterns? What are the usual data flows? Establishing these baselines is key to identifying deviations. Then comes real-time monitoring. You need to continuously collect and analyze telemetry data from every layer: endpoints, networks, applications, identity systems. This real-time stream of information is vital for spotting suspicious activity as it happens. Based on that monitoring, you perform risk assessment. During a risk assessment or an access request, right, you evaluate multiple signals: the user's behavior, the device's health, the location, the time, the sensitivity of the resources. You assign a risk score to that specific access attempt, and this leads to adaptive response. Based on the detected risk level, your system can then dynamically adjust the authentication requirements. If an access attempt is at low risk, perhaps standard MFA or multi-factor authentication is successes or sufficient. If it's at high risk, say a user is trying to access sensitive data from a new location at an unusual hour, the system might require additional authentication steps or even block access altogether and alert the security teams. This dynamic response makes your security posture much more resilient. While Zero Trust encompasses users, devices, and applications, the ultimate goal is often protecting the data. So, a data centric approach is vital within the Zero Trust framework. It begins with data discovery. You can't protect what you don't know you have. You need to identify regulated and sensitive information across all the storage repository, databases, file shares, cloud storage, etc. Once discovered, you need classification. Categorize your data based on its sensitivity and any regulatory requirements like GDPR, HIPAA, etc. This classification informs the level of protection needed. Then comes protection. Apply appropriate controls based on classification. This includes encryption of data at rest and in transit, robust access controls, and data loss prevention (DLP) technologies to prevent sensitive data from leaving where the data is stored. And finally, governance. You need to monitor and control information usage, regardless of where that data is stored or being accessed from. This ensures compliance with policies and regulations and helps prevent unauthorized access or misuse. Implementing Zero Trust is a journey, not a destination, and it requires a strategic approach. Start with an assessment, understand your current environment thoroughly, document your existing architectures, identify your most critical assets and data flows, and review your existing security controls. This gives you a baseline. Next is planning. Define your target Zero Trust architectures. What will it look like? Establish a conceptual framework that aligns your Zero Trust implementation with your organization's specific security requirements and business objectives. Prioritize based on risk. Consider a phased implementation. Trying to implement Zero Trust everywhere at once can be overwhelming. It's often best to begin with high value or high risk environments, perhaps applications handling sensitive data or user groups with elevated privileges. Gradually, expand the implementation to broader categories of resources as your capabilities mature and you gain experience. Finally, focus on integration. You likely have existing security infrastructure. The goal isn't necessary to rip and replace everything. Adapt your existing infrastructure where possible through technologies like security gateways, proxy architectures, and enhancing your monitoring capabilities to fit the Zero Trust model. The field of cybersecurity is constantly evolving, and the new technologies are enhancing Zero Trust capabilities. AI/ML is playing a significant role, particularly in behavioral analytics. Machine learning algorithms can analyze vast amounts of historical access patterns and contextual data to build dynamic risk scores for users and entities, improving anomaly detection. Cloud native security is embedding Zero Trust principles directly into cloud platforms. Service providers are offering integrated identity federation, granular microsegmentation controls, and API security mechanisms that align perfectly with Zero Trust architectures. DevSecOps practices are helping to embed security earlier in the application lifecycle rather than trying to retrofit controls later. By building security into development processes, we can ensure that applications are designed with Zero Trust principles in mind from the start. And finally, the development of standards and maturity models is helping organizations understand what a mature Zero Trust implementation looks like and providing frameworks for measuring their progress across various security domains. Finally, so, looking ahead, what's the future of Zero Trust? It's clear that Zero Trust architecture has emerged as a transformative security model. It fundamentally changes how we protect our valuable assets by addressing the inherent vulnerabilities of traditional perimeter based approaches. By implementing those continuous verification processes across all digital interactions, organizations are building far more resilient security frameworks. These frameworks are capable of protecting distributed resources effectively in today's complex computing environments. as implementation frameworks mature and the integration with technologies like artificial intelligence, cloud security, and DevSecOps deepens, zero trust capabilities will continue to evolve. This evolution will be crucial to studying and staying ahead of emerging threats and meeting the ever changing operational requirements of modern businesses. As I mentioned earlier, zero trust isn't a destination you reach and then stop. It's an ongoing strategy, a philosophy that will continue to adapt to the dynamic nature of technology and threats. It is the future of enterprise security. Thank you again, everyone, for your time and attention today. I am happy to take any questions that you may have. Feel free to let me know. Thank you again and have a great rest of your day. Bye bye.